Hello, everyone. It's very so honored to attend this conference. I'm Xiaowen Yang, scientist in MIT Economics and MIT Lab for Economic Analysis and Design. So today's presentation is about geographic data visualization and exactly what is geographic data visualization and how can it help people. So let's start from a demo. If I'm interested in understand the spatial and temporal trend of Thailand population growth, instead of getting a table, how about watching this animation? So from this, if you go to the website and click on the population button, you will see this animation. Each dot represents one province. The dot size represents the population size. Red color means positive population growth. Blue means negative. And yellow means stable growth. So it's very interesting to notice, but right now you can immediately notice from the late 1990s, very few provinces were actually gaining population. Of course, you can also click on the circle and get the actual numbers. So which means, with this application, the user can get the big picture in seconds. They don't have to go to all the different websites to download data and map them. And if we overlap this animation with other economic indicators, such as province, such as gross province product, and we probably can notice and detect more population migration pattern. So EconGIS website provides a convenient tool to understand the spatial pattern of over 1,000 indicators. We believe it is a powerful tool to facilitate research and decision making for researchers with geography background, public policy makers, and business analysts and the general public. So we'd like to collaborate with more countries and more institutions to make data easier to be understood. Thus, we can make the data much more accessible and much more useful. So here's today's agenda. First is a brief introduction of our current collaboration, then the introduction of the Thailand Econ WebGIS system. The third part is comparison of Econ WebGIS system to other social science WebGIS websites. Then the data and the technology behind the scenes. Then the benefits of collaborating and sharing. So here is the China.js website. From this map, you can immediately get two sense. First, the southeast part is the most populated district with a smaller county size. And the second, by the way, this one maps the percentage of population in secondary industry, which means manufacture. From this one, you can immediately realize here, this part is the center of the manufacture, which actually around Shanghai. Now this is map for the Brazil GIS website. And we can show that this one maps the family income by census data. And you can immediately realize this part is the most developed district, and that is actually São Paulo. So with all this website, so we are having collaboration with all the two websites, collaboration with China, Brazil. In China, we collaborate with the School of Government in Peking University. And in Brazil, we collaborate with the Brazil Climate Policy Initiative. And in US, we are going to collaborate with Professor Rajiv Chetty from Stanford, even though he already got his GIS team in-house, and I will explain why later on. Inside MIT campus, we also collaborate MIT Real Estate Entrepreneurship Lab, and our lab is MIT Lab for Economic Analysis and Design. For all these collaborations, we were supported by data, fund, and human resources because a lot of data cleaning and data aggregation were needed for each website. Now let's come back to the Thailand Econ WebGIS. As a favorite country in our research team, we actually had developed the most comprehensive website for Thailand, and with the most customized functions and the most data sets uploaded. And here is the major functions for this website. So I'm not going to read through, you can look at it. So the first one, the most important one, it takes a lot of time to develop, is a search and a map. So this is a demo, and this is a direct screen recording from laptop. So basically, the user can get the exact same experience if he's using the website in America, or if we have a mirror website in Thailand. That's what the people are going to use. Let's go back to explain. For example, if I'm interested in the question like salary or the payment in Thailand, so I type in the keyword, and I will get a list of all the variables in which could be provided by the different survey, and then pick the survey, and then pick the loop. It's too fast than what I can speak of. I can pick the survey and then pick the years. Then I generate the map. Now, right now it's by province. And if you click on that specific province, you will get the actual number. Okay. Wage. Pick the daily wage, NRD survey, 2001, mean value, wrong. Now I get a province value. If I think the province spatial resolution is too coarse, and if I need to go to want to get more detailed spatial information, I can change the unit to Tambon. So I can get a number. And I can also control the legend to change the color scheme. So now the next question would be, if I can see one indicators, so can I overlap the over 1,000 indicators? Yes, you can. Now, after mapping the wage, daily wage, if I click on the factory button and select LLC, weighted by investment, pick the same year as 2001. Now you can see the spatial pattern of LLC overlapped on the daily wage. So for a researcher, you probably can detect some spatial pattern. Now we go to the Tansan annual survey. Still, I have the question of daily wage in mind. If I click on the Tansan survey pattern and type in wage, I get a question of daily wage, and select urban annual survey, get mean value. Click OK. So you will get a value. Click on button on that specific province, you will get the value. We also developed several temporal animations. For this one, which shows the gross provincial product by year from 1980s. So you can immediately see that the economy, actually the developed speed is different. There are two corridors, one is here, one is here, develops much faster than other provinces. Then we have the print and the download function. After I have developed after I have picked my indicators and mapped them and changed the legend, I can decide to print it out or save a PDF copy on my screen, on my desktop. Give it a title. You can also download the data. The data will be on your desktop. It is a tabular data, and you can run your regression. And also, we also provide the upload function, which we generally in our team we use it as a way to for the error checking. So you upload your error term, and if your error term shows a strong spatial type pattern, that means you probably missed some important indicators in your equation. So here's the introduction about all the data sources behind this website. We have, for example, for the search and map functions, even for some very experienced people with GX background, if you want to map some specific indicators, generated will take days to collect the data from the sources, and then find out the linkage between the spatial data and the tabular data, the merge data, the map. But for this website, you can do all these things without any technology, without any geographic information system technology in seconds. So you can focus your time and energy on the research. And we have over 1,000 indicators from multiple sources. Generally, right now, we have uploaded from 4 sources: census, labor force survey, national NRD survey, and Townsend annual survey, which span over 20 years. And now is a comparison of our GIS website with other social science GIS website. And the reason I mention is a social science because the social science GIS website is very different with a typical GIS website. I will explain later. So we believe to compare all these kind of websites, there are 3 dimensions. The first is the spatial resolution. You should be able to provide the detailed information as detailed as possible. And then is the indicator's potential. So some GIS website provides very detailed information, like the census data mapper, which is supported by the US Census Department. But it's only provide about like 20 indicators. The speed is very fast. And a third dimension would be the speed, because for all websites, speed is important, but especially so for GIS website, because most GIS websites are very slow. And so slow that like users are less likely to use them. So we make this comparison, and the GeoFRED, which is a US St. Louis Fed, we supported, and they have the resolution about under the county level for US, which is about 3,000 units. And for the Econ GIS website, we can support up to 7,000 records to send to the users at the same time. So in Thailand, which means the Tambon level, much more units than the GeoFRED. And the World Bank data provide data at the country level, so which about just 100 or 100 countries. So it's not at the same magnitude at all. And for the indicators potentials, and we can, because of the structure, the database structure, we can provide unlimited indicators. It's not a limitation for us at all. And the same for the World Bank and the GeoFRED. For the speed, actually our speed is very fast, at the same level as the census data mapper. We compared with the GeoFRED, and the GeoFRED only map an indicator at US county level, which is about 3,000 units. The speed is about 10 seconds, and 30 seconds for the GeoFRED. And for us, for the Thailand, with around 7,000 indicators, we can do everything in the 10 seconds. And we are not so sure what's the server behind the other 3 servers on website. But for us, we know we are very late. We actually did everything in the 3 countries in 1 server, which is similar to a desktop. And the reason it's so important is which means it will be easy to maintain. And then also it's easier for us to distribute a mirror website to our collaborators. So why we can do this, I mean, with all the 3 dimensions to be the best, and also it's also very lightweight. It's because we planned very carefully for every step and optimize the work. So it's very hard work behind the scenes. First, we need to choose the technology platforms. And by the time we choose a technology, we have 3 guidelines. First, the platform should be expandable, developable, which means we can build our customized functions and easy to maintain and update. So because our collaborators, we don't expect our collaborators to have a very special JS and website team to maintain it. It should be able to be maintained by a typical IT person and lightweight. So by then, there's 3 products on the mainstream product, GeoServer, which is open source software. And it's lightweight, but it meets some important advanced function, which is crucial for us. And then MacBook. MacBook is a very popular platform recently, and actually used by the Rajiv team. Light one is good when you have 1 or 2, just like less than 10 indicators, and you just want to upload and show. But when you have over 1,000 indicators with a database under the back, it will be different. It will be difficult to use that one. And so we decided to choose ArcGIS Web Server. It has a dynamic join function, which makes the whole website optimization great. So why the social science, GIS website for social science is different with typical GIS website? Because so for the social science, the spatial component actually is very light. In the Thailand case, it just takes like less than 1 gigabyte. But the indicator, like tabular data, takes several gigabytes. Like the NRD survey, the 1 survey data takes like 6 gigabytes. And so, but for a typical GIS website, the structure is different. The spatial component is the largest. For a GIS website, spatial component is the largest components. Generally take about 18% of the storage, and the tabular data is 20%. So it's a worse direction. And so the typical GIS website is a spatial component with about like 10 to 20 indicators for each layer, and then they end up like multiple layers to show, to send it to the users. But in our case, with over 1,000 indicators, we will end up with over 1,000 layers, which makes it difficult to store storage, and make it very difficult to program and manage. So this is the database structure for the Thailand Icon WebGIS database. So we have a spatial data, and it's just the bone data, basically the spatial boundary and the ID. And then we have another traditional geodatabase for indicator data. And each layer of each table has a spatial ID. And then we join these 2 data sets, enter the error, then send it to the users. So which means we don't have any redundancy, and that's the reason we can have such a high efficiency for both speed and storage, and being lightweight and fast. And here's a software structure for the GIS server and the database server. So we try to pick, for every server, we try to pick the typical one. But here there's, if you happen to have some IT person, the SQL database, we choose the PostgreSQL instead of MySQL. It's because the PostgreSQL works with the spatial data much better. And then another thing is data processing. Some GIS data website, they do the processing in the air, like the mean value and the median value, which means we'll slow down the process. So we did everything beforehand. So which means we, in the Thailand case, we aggregate to Tambon, Ambon, and province level, but we don't provide any data at the village level to protect privacy. And we also distinguish categorical data and numeric data. So to give percentage for each category. But during the aggregation, we spent a lot of time just to figure out what is a non-value automatically, because it's even for the data from the same data source and different years, the non-value could be different. And also, another time-consuming work is about aggregating. It's about indicator description. This indicator description is the major function to support the search function. If you type in the keyword, and we can automatically give you a list of indicators which you could search, you could map for. And we write some program to make the process automatically, but at the very end, still we need somebody to read through the documentation one by one. That's very, time consuming. And so here's the next step. What we hope we can develop a next one. First, of course, uploading more data, because the more comprehensive the data set, and the more likely you can compare and cross-validate data set and make it more useful. And also, we picked the platform 5 years ago. By then, Flex is a very popular language among the IT world, but now it's kind of outdated. So we would like to switch to JavaScript. So it's like the same logic. It's almost like translation for different languages. And also, we want to have more. We want to hear from the user and have more customized functions. So now here's wrapping up. So we believe this one, seeing is knowing. We believe this GIS website provides an important tool, very convenient for the end users, for researchers without geography background, for business analysts and public policy makers, general public, to understand the data and to use the data. And it saves time and it inspires researchers to do more, to realize there may be some pattern and to do some realize some interesting questions and to do research. And we'd like to collaborate and share with small institutions here and by data and by output. And also we want to hear from you. How would you like the functions to be? And which data set would you like to upload? Okay. Here's my presentation.